Hello, in this lecture we will find the area of triangle ABC in two different ways. In the drawing we have triangle ABC, side AB of triangle ABC equals to 8 units, side AC equals to 14 units, and we also know that the angle ACB equals to x degrees in size, and angle ABC, this angle equals to 2x degrees in size, and we want to find out the area of this triangle ABC. So first of all we will make a construction. From point A we will draw a line segment AD that touches side BC of triangle ABC in such a way that the line segment starts from point A, and the touching point between side BC of the triangle and the line segment will be defined as point D, and we created the line segment AD in such a way that the angle ADB will be equal to 2x. So actually in triangle ABD we have two equal angles. Those two angles are equal to each other. Both of those two angles are equal to 2x degrees in size, and we have a rule number 1 that states that in front of equal angles in the triangle there are equal sides. So I will read rule number 1 again. Rule number 1 states that in front of equal angles in the triangle there are equal sides. So actually if we have triangle ABC that has two equal angles, this is angle alpha and this is also angle alpha, so triangle ABC has two equal angles. Those two angles are equal to each other. According to rule number 1, in front of this angle, angle alpha, we have side AB of triangle ABC, and in front of this angle alpha we have side AC of triangle ABC. According to rule number 1, AB, side AB equals to side AC, because of the fact that side AB is in front of this angle alpha and side AC is in front of this angle alpha, and according to rule number 1, the sides that are in front of equal angles are also equal between them. So those two sides are in front of equal angles, therefore they are also equal between them, according to rule number 1, that is to say AB equals to AC. Okay, again we have in front of this angle alpha we have side AB of triangle ABC, and in front of this angle alpha we have side AC of triangle ABC, and according to rule number 1, the sides that are in front of equal angles are also equal between them, that is to say AB equals to AC. Okay, so we actually can implement rule number 1 in our drawing, because triangle ABD we have this triangle ABD, angle ABD, this angle equals to angle ADB, and both those two angles are equal to 2x, so triangle ABD has two equal angles. So in front of this angle 2x we have side AB of triangle ABD, and in front of those angle 2x we have side AD of triangle ABD. So according to rule number 1, AB equals to AD. AB equals to AD according to rule number 1. Okay, according to rule number 1, side AB equals to side AD in triangle ABD, but we know that side AB equals to 8 units. It is given us in the question. AB equals to 8 units. So from this equality we can deduce that AD also equals to 8 units. Okay, AD also equals to 8 units. AD equals to 8 units, and we have another rule, rule number 2, before I present to you rule number 2, I will explain you what is external angle, exterior angle, and what is interior angles in triangle. So actually, if we have triangle ABC, that can be any triangle, not necessarily our triangle ABC, but any other triangle. Angles alpha and beta are defined as interior angles because they are inside triangle ABC, so they are defined as interior angles. While angle ABL, this angle is defined as exterior angle. Exterior angle because it is located outside triangle ABC. That is the reason that is defined as exterior angle. And actually those two angles, alpha and beta, are located in the opposite direction of this angle. Therefore, they are defined as opposite interior angles. So, in relation to this angle, angle gamma, they are located in opposite sides in relation to angle gamma. Therefore, they are defined as opposite interior angles in relation to angle gamma. And angle ABL is defined as exterior angle. So rule number 2 states that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So I will read rule number 2 again. Rule number 2 states that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Okay? I will read rule number 2 again. The exterior angle of a triangle is equal to the sum of the two opposite interior angles. So, actually, according to rule number 2, the exterior angle ABL, is equal to the sum of the two opposite interior angles. That is to say, angle ABL equals to angle alpha plus angle beta. Okay, so according to rule number 2, the exterior angle ABL equals to the sum of the two opposite interior angles. That is to say, it equals to alpha plus beta. Okay, so according to rule number 2, angle ABL, the exterior angle ABL, equals to the sum of the two opposite interior angles. That is to say, it equals to alpha plus beta. Okay, again, the exterior angle ABL equals to the sum of the two opposite interior angles. That is to say, ABL equals to alpha plus beta. Okay, so again, we can implement rule number 2 in our drawing. We have triangle ADC. In relation to triangle ADC, this triangle angle DAC and angle ACD are opposite interior angles while angle ADB is defined as exterior angle in relation to triangle ADB. So I will read again the printed I wrote. Angles DAC and ACD are defined as opposite interior angles. Those two angles are defined as opposite interior angles, while this angle ADB, is defined as exterior angle in relation to triangle ADC. Okay, so according to rule number 2, the exterior angle ADC that equals to 2x equals to the sum of the two interior angles. That is to say, it equals to angle DAC, this angle, plus angle ACD. Again, according to rule number 2, the exterior angle 2x, this exterior angle in relation to this triangle, the exterior angle 2x equals to the sum of the two opposite interior angles. It equals to the sum of the two opposite interior angles. So 2x equals to angle DAC plus angle ACD. Okay, but we know that angle ACD equals to x degrees in size, so we can substitute in the equality angle ACD by x, because angle ACD equals to x degrees in size. Okay, here we substituted angle ACD by x because angle ACD equals to x according to what is given us in the question. So in this equality we can substitute x. So here 2x minus x is x. So we will get that angle DAC equals to x degrees in size. Okay, angle DAC equals to x degrees in size. Actually, in triangle ADC, we have two equal angles. Both those two angles are equal to x degrees in size. So, in triangle ADC, we have two angles that are equal to each other. Okay, in triangle ADC, we have two angles that are equal to each other. Both those two angles are equal to x degrees in size. Therefore, according to rule number 1, that states that in front of equal angles there are equal sides. So in front of this angle we have side line segment side DC of triangle ADC, and in front of this angle we have side AD of triangle ADC. According to rule number 1, in front of equal angles there are equal sides, so DC will be equal to AD. Okay, according to rule number 1, DC equals to AD. Okay, DC equals to AD according to rule number 1, because of the fact that in front of equal angles we have equal sides. Those two sides are in front of equal angles, therefore they are also equal to each other. That is to say, AD equals to DC. Okay, according to rule number 1. But we have already found out that AD equals to 8 units. AD equals to 8 units in size. AD equals to 8 units in size. So from this equality we can deduce that DC also equals to 8 units. Okay, DC also equals to 8 units. So DC equals to 8 units in size, and we also have rule number 3 that relates to an isosceles triangle. First of all, I will explain you what is the base of an isosceles triangle. If we have an isosceles triangle, this triangle ABC is an isosceles triangle. That is to say, AB equals to AC, AB equals to AC, side AB equals to side AC. Those two sides are equal to each other. So side BC is defined as the base of the isosceles triangle ABC. Is the base of the isosceles triangle ABC. Okay, again, side BC is the base of the isosceles triangle ABC. We know that AB equals to AC, so side BC is the base of triangle ABC, that is an isosceles triangle. So actually rule number 3 states that the height to the base in an isosceles triangle, the height to the base in an isosceles triangle divide the base into two equal parts. I will read rule number 3 again. Rule number 3 states that the height to the base in an isosceles triangle divide the base to two equal parts. Okay, so actually this triangle is an isosceles triangle because AB equals to AC, and according to rule number 3, the height to the base creates 90 degrees with the base. So from point A we will draw height to the base BC. So this is the height to the base BC, and this angle is a right angle, and this angle also equals to 90 degrees. And we will define the touching point between the height to side BC of triangle ABC as point D. Then, according to rule number 3, the height to the base, that is AD, divides the base BC to two equal parts. That is to say, BD equals to DC. Okay, BD equals to DC. BD equals to DC. According to rule number 3, the height AD to the base, that is BC in triangle ABC, divides the base BC to two equal parts. That is to say, BD equals to DC. Okay? The height to the base is AD. I will write here height. So the height to the base creates 90 degrees with the base BC, and it also divides the base BC to two equal parts. That is to say, BD equals to DC. Okay, so, and again we can implement rule number 3 in our drawing. We have angle and triangle ABD. Actually, triangle ABD, this triangle is an isosceles triangle because AB equals to AD. AB equals to AD, therefore triangle ABD is an isosceles triangle. Okay, so I'll write it down. Triangle ABD is an isosceles triangle because side AB of triangle ABD equals to side AB equals to side AD in triangle ABD. Therefore, triangle ABD is an isosceles triangle. Therefore, according to rule number 3, the height and the base of triangle ABD is BD. the base of triangle ABD is BD, so according to rule number 3, the height to the base BD, therefore this angle, first of all, this angle is a right angle because the height creates 90 degrees with the base, and this angle is also a right angle. I will define the height as h, abbreviation for height, and we will define the touching point between side BD of triangle ABD to the height h as point E. Point E is the touching point between the height and side BD of triangle ABD. So according to rule number 3, the height AE to the base BD divides the base BD to two equal parts, that is to say BE equals to ED. Okay, so BE equals to ED, according to rule number 3, BE equals to ED because of the fact that the height AE divides the base BD to two equal parts, therefore BE equals to ED, and we will define BE as A, that is to say BE equals to A. Okay, BE equals to A. So from this equality we can deduce that ED also equals to A. ED also equals to A. ED equals to A. Okay. Actually, as you can see from the drawing, we have inside triangle ABC we have two right triangles. This triangle ABE is a right triangle, triangle ABE is a right triangle, again the green triangle is a right triangle because it has angle AEB that equals to 90 degrees, therefore triangle ABE is a right triangle. Okay, triangle ABE, the green triangle ABE is a right triangle, because it has angle AEB that equals to 90 degrees. Angle AEB equals to 90 degrees. Okay, so triangle AEB is a right triangle because angle AEB equals to 90 degrees. Therefore, we can implement the Pythagoras theorem in the right green triangle, triangle AEB. So according to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. That is to say, the hypotenuse of triangle ABE is AB, so AB squared, the square of the hypotenuse is AB squared, equals to the sum of the squares of the perpendiculars. The sum of the square of the perpendiculars is BE squared plus AE squared. So according to the Pythagoras theorem, in the right triangle, triangle ABE, the square of the hypotenuse is AB squared equals to the sum of the squares of the perpendiculars equals to BE squared plus AE squared. But what is the value of AE? AE equals to 8 units according to what is given us in the question. So AB squared will be equal to 8 squared, that is 64. Equals to BE squared. BE equals to A according to our definition. So BE squared will be equal to A squared plus AE squared. AE equals to H according to our definition, so it is AE squared is H squared. So in total we got that 64 equals to A squared plus H squared. Here we will subtract A squared from this equation number 1, and we will get that H squared equals to 64 minus A squared. Okay, equation number 1 states that H squared equals to 64 minus A squared. Okay. And here we have triangle AEC is also right triangle. Okay, the triangle in the orange color Okay, the triangle in the orange color, triangle AEC, is also a right triangle because angle AEC is a right angle. Okay, triangle AEC is a right triangle because angle AEC is a right angle, it equals to 90 degrees. Angle AEC is a right angle therefore triangle AEC is a right triangle, so we can implement the Pythagoras theorem in the right triangle, the right orange triangle, triangle AEC. According to the Pythagoras theorem, the square of the hypotenuse, that is AC square, equals to the sum of the squares of the perpendiculars, equals to AE square plus EC square. According to Pythagoras theorem, the hypotenuse is AC in triangle AEC, therefore the square of the hypotenuse is AC square equals to the sum of the squares of the perpendiculars, equals to AE square plus EC square. But what is the value of AC? AC equals to 14 units, therefore AC square will be equal to 196. AC equals to 14 units, so AC square will be equal to 196. And AE equals to H, so AE square is H square plus EC square. EC equals to A plus 8. Again, EC equals to A plus 8. So EC square is A plus 8 square. So in total we got that 196 equals to 8 squared plus a plus 8 squared. And we have already found out in equation number 1 that 8 squared equals to 64 minus a squared. So we can substitute 8 squared by 64 minus a squared, because 8 squared equals to 64 minus a squared. So 196 equals to 8 squared is 64 minus a squared, and a plus 8 squared is a squared plus 64 plus 16a. So in total we'll get that 196 equals to 64 plus 64 is 128, and minus a squared plus a squared is 0, so a squared is cancelled. So in total we will get that 196 equals to 128 plus 16a. Here we will subtract 128 from equation number 2, and we will get that 16a equals to 196 minus 128 is 68. So here we will divide the question number 2 by 16 in order to get the value of a, and we will get that a equals to 68 over 16. We got that a equals to 68 over 16. We will divide the numerator and the denominator by 4, and 68 over 4 is 17, and 16 over a over 4 is 4. So a equals to 17 over 4 units. So actually BE equals to A and ED equals to A. We found out the value of A, and we have equation number 1 that states that 8 squared equals to 64 minus a squared. Here we will square this equality in order to get the value of a, and we will get that a squared equals to 17 squared is 289 over 4 squared is 16. So a squared equals to 289 over 16. Okay, so we substitute a squared by 289 over 16, and we will get that a squared equals to 64 minus a squared is 289 over 16. So here we will multiply 64 by 16 and then we will divide it by 16 in order to have a common factor with this number, and we will get that x squared equals to 64 times 16 is 1024 minus 289 over 16. So in total we got that x squared equals to 1024 minus 289 over 16. 1024 minus 289 is 335, so I write it down. So in total we got that h squared equals to 735 over 16. So here we will take a root out of this equality in order to get the value of h, and we will get that h equals to the root of 735 over 16. But 735 equals to 15 times 7 times 7 over 16, and actually h equals to the root of 15 times 7 times 7, and 16 equals to 4 times 4. So h equals to the root of 15 times 7 times 7 over 4 times 4. The root of 7 times 7 is 7, and the root of 4 times 4 is 4. So we can take 7 over 4 out of the root. So h equals to 7 over 4 times root 15 units. Okay, h equals to 7 over 4 times root 15 units, and we have already found out that a equals to 17 over 4 units. Okay, so we have the values of h and a, and now it will be very easy to find out the area of triangle ABC, because the area of any triangle equals to A is abbreviation for area. The area of any triangle equals to the base of the triangle times the height to the base over 2. Again, the area of any triangle, the formula for the area of any triangle equals to the base of the triangle times the height to the base over 2. And you should remember that the height must create 90 degrees with the base. Otherwise it is not the height. So the area of triangle ABC according to this formula will be equal to the base of the triangle. The base of triangle ABC is BC times the height. The height of triangle ABC is AE that equals to H, and AE that equals to H is indeed the height because it creates 90 degrees with the base BC. This angle is 90 degrees and this angle is 90 degrees. The height H creates 90 degrees with the base BC, therefore the height is indeed H. Okay, so it is BC times the height that is H over 2. Again, A is the relation for area, so the area of triangle ABC equals to the base of the triangle that is BC times the height that is H over 2. The area of triangle ABC equals to the base that is BC times the height that is H over 2. But what is the value of BC? The value of BC equals to A plus 8. Again, the value of BC, side BC of triangle ABC, equals to A plus 8. Or BC equals to 2A plus 8. And we have already found out that H equals to 7 over 4 times root 15 units. So, in total, the area of triangle ABC equals to 2 times A plus 8 times 7 over 4 times root 15 over 2. What is the value of A? A equals to 17 over 4 units, so we can substitute A in this equality by 17 over 4 units. So 17 over 4 units times 2 will be equal to 17 over 2. So I write it down. So the area of triangle ABC equals to 2A is 17 over 2 plus 8 times 7 over 4 times root 15 over 2. So the area of triangle ABC equals to 17 over 2 plus 8 times 7 over 4 times root 15 over 2. 4 times 2 is 8, and here we will write 16 over 2 instead of 8 in order to have a common factor with this number. So in total we will get that the area of triangle ABC equals to 17 over 2, and instead of 8 we will write 16 over 2, that is equal to 8 plus 16 over 2 times 7 times root 15 . 2 times 4 is 8. So in total we got that the area of triangle ABC equals to 17 plus 16 over 2 times 7 times root 15 over 8. 17 plus 16 is 33, and 2 times 8 is 16, so I'll write it down. So the area of triangle ABC equals to 33 times 7 over 16 times root 15. The area of triangle ABC equals to 33 times 7 times root 15 over 16. 33 times 7 is 231. So I'll write it down. So the area of triangle ABC equals to 231 times root 15 over 16 square units. Okay, so the final answer to the question is that the area of triangle ABC equals to 231 times root 15 over 16 square units. Okay. Again, the area of this triangle ABC equals to 231 times root 15 over 16 square units. Okay, so that was the first method to find out the area of triangle ABC. Now I will present to you a second method to find out the area of triangle ABC. So, first of all, we will find the value, the size of angle A. We know that the sum of the angles in any triangle equals to 180 degrees. So, and especially in this triangle ABC, the sum of its angles is equal to 180 degrees. That is to say, angle A plus angle B plus angle C must be equal to 180 degrees. So we'll write it down. Angle A plus angle B plus angle C must be equal to 180 degrees. Okay. The equality states that the sum of the angles is equal in triangle ABC equals to 180 degrees. Okay, so angle A plus angle B equals to 2x degrees. It is given us in the question. So it is, I will substitute angle B by 2x because angle B equals to 2x degrees in size, plus angle C equals to x degrees in size. all equals to 180 degrees. So we got the equality that states that angle A plus 2x plus x equals to 180 degrees. So 2x plus x is 3x, so I'll write it down. So angle A equals angle A plus 3x equals to 180 degrees. Here we'll subtract from this equality 3x in order to get the value of angle A. We'll get the angle A equals to 180 degrees minus 3x. So we found out the size of angle A. Angle A equals to 180 degrees minus 3x. So we can write here that angle A equals to 180 degrees minus 3x. Okay. So in the next step, I will present to you rule number 4, that is actually a new formula for the area of any triangle. So in rule number 4, I will present to you a new formula for the area of any triangle. So according to rule number 4, if we have a triangle ABC that can be any triangle, not necessarily our triangle, but any other triangle, and we know that the size of side AB of triangle ABC equals to A units, and the size of side AC of triangle ABC equals to B units. And we also know that the angle between side AB and side AC equals to theta. Then, according to rule number 4, the area of this triangle, triangle ABC, area of triangle ABC equals to A times B times sinus theta over 2. Again, the area of any triangle equals to A times B times sinus theta over 2. Okay, so we actually can implement this formula in our triangle ABC according to the formula that I presented to you. The area of this triangle ABC, A is the abbreviation for area. The area of triangle ABC will be equal to AB times AC times sine of 180 degrees minus 3x over 2. So the area of triangle ABC, according to the formula that I presented to you, will be equal to AB times AC times sine of 180 degrees minus 3x over 2. But what is the value of AB? AB equals to 8 units according to what is given us in the question. And what is the value of AC? AC equals to 14 units according to what is given us in the question, times sine of 180 degrees minus 3x over 2. So the area of triangle ABC equals to 8 times 14 over 2 times sine of 180 degrees minus 3x. Here 14 over 2 is 7, and 7 times 8 is 56. So I'll write it down. The area of triangle ABC equals to 56 times sine of 180 degrees minus 3x Okay, so we found out that the area of triangle ABC equals to 56 times sine of 180 degrees minus 3x. So here we have trigonometric identity for the value of sine 180 degrees minus 3x according to the following trigonometric identity. Sine of 180 degrees minus alpha equals to sine alpha. So according to this trigonometric identity, sine of 180 degrees minus alpha, sine of 180 degrees minus 3x equals to sine 3x. So I will write it down. So the area of triangle ABC will be equal to 56 times sine of 3x. Okay, so according to equation number 1, the area of triangle ABC equals to 56 times sine 3x. Okay, in the next step, I will present to you rule number 5, that is actually the law of sines. Rule number 5 is the law of sines. So what is the law of sines? First of all, I must emphasize that the law of sines is valid in any triangle. We can use it in any triangle. In any triangle. Again, we can use the law of sines in any triangle. So actually, if we have any triangle, that triangle ABC can be any triangle, and we know that the size of side BC of triangle ABC is A units, and we also know the size of side AC of triangle ABC is B units, and the size of side AB of triangle ABC is C units. So according to the law of sines, A over sinus A equals to B over sinus B equals to C over sin C. Again, in triangle ABC, it can be any triangle. A over sinus A equals to B over sine B equal to C over sine C, when capital A, capital B and capital C are the sizes of the angles. Capital A is the size of this angle, capital B is the size of this angle, and capital C is the size of this angle. Okay? So, and again, we can use the law of sines in our triangle ABC, because it can be used in any triangle. It can be used in any triangle. So we will use it, the law of sines, in our triangle ABC, and according to the law of sines in our triangle ABC, AB over sine X will be equal to AC over sine 2x. Again, AB over sine X equals to AC over sine 2x according to the law of sines. Okay? But what is the value of AB? AB equals to 8 units according to what is given us in the question. So it is 8 over sine X equals to AC over sine 2x. What is the value of AC? AC equals to 14 units according to what is given us in the question. So in total we got that 8 over sine x equals to 14 over sine 2x. And again we have a trigonometric identity for the value of sine 2x. According to the following trigonometric identity, sine 2x equals to 2 sine x cosine x. Okay, so we will substitute sine 2x by this expression in this equality, because sine 2x equals to this expression, and we will get that 8 over sine x equals to 14 over sine 2x equals to 2 sine x cosine x, according to this trigonometric identity. Okay. So here we have sine x in the denominator of this side of the equation, and we have sine x in the denominator of the other side of the equation, so we can cancel sine x. And 14 over 2 is 7. So I'll write it down that 8 equals to 7 over cosine x. So in total we got that 8 equals to 7 over cosine x. Here we will multiply this equality by cosine x, and then we will divide it by 8, and we will get that cosine x equals to 7 over 8. So we found out that cosine x equals to 7 over 8. In the next step, we will find out the value of sine x according to the following trigonometric identity. Sine square x plus cosine square x equals to 1. Okay, we have this trigonometric identity, and from this trigonometric identity we will find out the value of sine x. Here we will subtract cosine square x from this trigonometric identity, and we will get that sine square x equals to 1 minus cosine square x. So here we will take a root out of this equality in order to get the value of sine x. We will get that sine x equals to the root of 1 minus cosine square x. Okay, so sine x equals to the root of 1 minus cosine square x. So we know that cosine x equals to 7 over 8. We will square this equality in order to get the value of cosine square x. Cosine square x will be equal to 7 squared over 8 squared. 7 squared is 49 and 8 squared is 64. So cosine square x equals to 49 over 64. So here we can subtract cosine square x by 49 over 64, and we will get that we substitute cosine square x by 49 over 64, and we will get that sine x equals to the root of 1 minus 49 over 64. We got that sine x equals to 1 minus 49 over 64. Here, instead of 1, I will write 64 over 64 in order to have a common factor in this number. So sine x equals to the root of 64 over 64 minus 49 over 64. So here 64 minus 49 is 15, so I write it down. We get the value of sine x. Sine x will be equal to the root of 15 over the root of 64 is 8. So we found out that sine x equals to root 15 over 8. Okay, now we will return to equation number 1, that is the area of triangle ABC. According to equation number 1, the area of triangle ABC equals to 56 times sine 3x. Okay, we found out in equation number 1 that the area of triangle ABC equals to 56 times sine x. In the next step I will present to you a trigonometric identity for the value of sine 3x. According to this trigonometric identity, the value of sine 3x equals to 3 sine x minus 4 sine cube x. Okay, according to this trigonometric identity, the value of sine 3x equals to 3 sine x minus 4 sine cube x. So we will substitute sine 3x in equation number 1 by this expression that equals to sine 3x. Okay, and we will get that the area of triangle ABC equals to 56. Instead of sine 3x, we'll write down 3 sine x minus 4 sine cube x. That is actually equals to 3 sine x. So here we'll take a common factor sine x from this equality. We'll take out the common factor sine x from this equality, and we'll get that the value now of triangle ABC equals to 56 times sine x. In the brackets we took out sine x as a common factor of this expression. In the brackets we will have 3 minus 4 sine square x. Okay, so the area of triangle ABC equals to 56 times sine x times 3 minus 4 sine 2x. But we have already found out that sine x equals to root 15 over 8. So I write here that sine x equals to root 15 over 8. And we will square this equality in order to find out the value of sine square x. We need the value of sine square x because we have here expression with sine square x. So sine square x will be equal to 15 over 64 okay, sine square x equals to 15 over 64. In the next step, we'll substitute sine x by root 15 over 8, and we'll substitute sine square x in this expression by 15 over 64. Okay. We get that the area of triangle ABC equals to 56 times sine x equals to root 15 over 8. In the brackets we have 3 minus 4 sine square x equals to 15 over 64. So in total we got that the area of triangle ABC equals to 56 times root 15 over 8 times 3 minus 4 times 15 over 64. Here 56 over 8 is 7, and here we divide the denominator by 4, and we will cancel 4, this 4. 64 over 4 is 16. So I write it down. The area of triangle ABC equals to 56 times root 15 over 8 3 minus 15 over 16. So in total we got that the area of triangle ABC equals to 56 times root 15 over 8 times 3 minus 15 over 16. Here 56 over 8 is 7, so I write it down. So the area of triangle ABC equals to root 15 times 7 3 minus 15 over 16 in total we got that the area of triangle ABC equals to root 15 times 7 3 minus 15 over 16. Here instead of 3 I will write down 48 over 16 that equals to 3 in order to have a common factor with this number. Okay, we will get that the area of triangle ABC equals to root 15 times 48 minus 15 over 16. So in total we got that the area of triangle ABC equals to root 15 times 48. Here I forgot 7. This is root 15 times 7. And 48 minus 15 is 33, so I write it down. So the area of triangle ABC equals to root 15 times 7 times 33 over 16. So here we got that the area of triangle ABC equals to root 15 times 7 times 33. 33 times 7 is 231 over 16, so I write it down. The final answer is that the area of triangle ABC equals to root 15 times 231 over 16 square units. Okay, so the final answer to the question is that the area of triangle ABC equals to root 15 times 231 over 16 square units. Okay, so that is actually the final answer to the question that the area of this triangle ABC equals to root 15 times 231 over 16 square units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the area of this triangle ABC, and we know that AB equals to 8 units, AC equals to 14 units, and this angle is angle X, and this angle is angle 2X. Actually, we made construction, we draw line segment AD that touches side BC at point D, and we draw line segment AD in such a way that angle ADB equals to 2x, exactly like the same as this angle, the same size of this angle, the same size of angle ABC, that also equals to 2x. So in triangle ABD we have two equal angles. Those two angles are equal to each other. Both of them are equal to 2x. And we have rule number 1 that states that in front of equal angles in the triangle there are equal sides. So according to rule number 1, if we have triangle ABC that has two equal angles, that is to say those two angles are both equal to alpha, then according to rule number 1, in front of those equal angles there are equal sides. Side AB is in front of this angle alpha, and side AC is in front of this angle alpha. So according to rule number 1, the sides are also equal to each other. The sides that are in front of equal angles are also equal to each other. That is to say AB equals to AC. Okay? So in front of equal angles there are equal sides. That is to say AB equals to AC. Okay? So again we can implement rule number 1 in our triangle. We have triangle ABD that has two equal angles. Those two angles are equal to 2x. So according to rule number 1, in front of equal angles there are equal sides. That is to say, in front of this angle we have side AB, and in front of this angle we have side, in front of this angle we have side AD, and in front of this angle we have side AB. So according to rule number 1, AB equals to AD. Okay, AB equals to AD according to rule number 1. But we know that AB equals to 8 units. It is given us in the question. AB equals to 8 units, and from this equality we can deduce that AD also equal to 8 units. Okay, AD also equal to 8 units. So AD equals to 8 units. And then we have also rule number 2. Explain to you what is interior angle and what is exterior angle. In this triangle ABC, we have actually 3 interior angles. Alpha, beta, and gamma are interior angles. And those 2 angles, angle alpha and beta, are located in the opposite sides in relation to angle gamma. Therefore, they are opposite interior angles. And angle ABL is exterior angle, and according to rule number 2 states that the exterior angle of a triangle is equal to the sum of the 2 opposite interior angles. Okay, so the exterior angle ABL is equal to the sum of the 2 opposite interior angles. That is to say, angle ABL equals to alpha plus beta. And again, the exterior angle ABL is equal to the sum of the 2 opposite interior angles. That is to say, angle ABL, this angle, equals to alpha plus beta. Okay, and again we can implement rule number 2 in our drawing, because we have here triangle ADC. In triangle ADC, those 2 angles are opposite interior angles in relation to this angle. Those 2 angles are defined as interior angles, opposite interior angles, and angle ADB is defined as exterior angle of triangle ADC. Angle ADB is exterior angle of triangle ADC. So this exterior angle that equals to 2x equals to the sum of those 2 angles. Okay, so according to rule number 2, the exterior angle that equals to 2x will be equal to the sum of the 2 opposite interior angles. It equals to angle DAC plus angle ACD. It equals to angle DAC, this angle, plus angle ACD. Okay, but we know that angle ACD equals to x. It is given us in the question. So we can substitute angle ACD by x, because angle ACD equals to x, where we get that 2x equals to angle DAC plus x. Here we subtracted x from this equality, and we got that angle DAC also equals to x. This angle is also equals to x. So actually, in triangle ADC we have 2 equal angles, and according to rule number 1, in front of equal angles in the triangle we have equal sides. In front of this angle we have side DC of triangle ADC, and in front of this angle we have side AD. So according to rule number 1, AD equals to DC. Okay, according to rule number 1, AD equals to DC. But we know that AD equals to 8 units. Okay, we know that AD equals to 8 units. So from this equality, we can deduce that DC equals to 8 units. Okay, DC equals to 8 units. This angle, this side equals to 8 units. DC equals to 8 units. And then I presented to you also rule number 3, that relates to isosceles triangle. First of all, in an isosceles triangle, we have two sides that are equal to each other. So if triangle ABC is an isosceles triangle, then AB equals to AC, and the base of triangle ABC is BC. Okay, so and according to rule number 3, the height to the base in an isosceles triangle divides the base to two equal parts. Okay, so the height to the base in an isosceles triangle divides the base to two equal parts. So the height AD is the height to the base BC. The height creates 90 degrees with the base, so the height, the red line, the red straight line, the height AD divides the base BC to two equal parts. That is to say, BD equals to DC. Again, the height to the base in an isosceles triangle divides the base to two equal parts. That is to say, BD equals to DC. Okay, that is rule number 3, and again we can implement rule number 3 in our drawing, because we have here isosceles triangle. Triangle ABD is an isosceles triangle because AB equals to AD. Therefore, triangle ABD, this triangle, is an isosceles triangle. And according to rule number 3, if we draw height from point A to the base BD of the isosceles triangle ABD, the height AE divides the base BD to two equal parts. That is to say, BE equals to ED. Okay, so according to rule number 3, the isosceles triangle ABD, the height AE divides the base BD to two equal parts. That is to say, AB equals to AD. Okay, the height AE divides the base BD to two equal parts. That is to say, BE equals to ED. And if we define BE as A, that is to say, if BE equals to A, then according to this equality, we can deduce that ED also equals to A. Okay, from this equality, we can deduce that ED also equals to A. So we found out that BE equals to A and ED equals to A. And then you can see from the drawing that we have two right triangles in the big triangle, triangle ABD. The green triangle is a right triangle, and the orange triangle is also a right triangle. Therefore, we can implement the Pythagoras theorem in those two triangles. Those two right triangles, we can implement the Pythagoras theorem in those two right triangles. So triangle ABE again is a right triangle because it has angle that equals to 90 degrees, angle AEB equals to 90 degrees. Therefore, the green triangle, triangle ABE, is a right triangle. Therefore, we can implement the Pythagoras theorem in the right triangle ABE. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is AB square equals to the sum of the squares of the perpendiculars equals to BE square plus AE square. So in the right triangle ABE, AB square equals to BE square plus AE square. But AB equals to 8 units. So AB square is 8 square is 64. And BE equals to H. So BE square is H square. AE equals to H. So AE square, each S is H square. And BE equals to A. BE equals to A. So BE square is A square. So in total we got that 64 equals to A square plus H square. And from this equality, we got that h squared equals to 64 minus a squared. That is equation number 1, that h squared equals to 64 minus a squared. Okay, and we also have the orange triangle. The orange triangle is also a right triangle because it has one angle that equals to 90 degrees. Angle AEB in the red triangle, in the orange triangle, equals to 90 degrees. Therefore, the orange triangle AEC is a right triangle. Therefore, we can implement the Pythagoras theorem in the orange triangle AEC that states that the square of the hypotenuse, that is AC square, equals to the sum of the squares of the perpendiculars, equals to AE square plus EC square. Okay, so in the right triangle AEC, the square of the hypotenuse, AC square, equals to the sum of the squares of the perpendiculars, equals to AE square plus EC square. We know that AC equals to 14 units, so AC square is 14 square is 196, and AE equals to H, so AE square is H square, and EC equals to A plus 8. Again, EC equals to A plus 8, so AEC square is A plus 8 square. So in total we got that 196 equals to 8 square plus A plus 8 square, but we have already found out that H square equals to 64 minus A square. So we can substitute AH square by 64 minus A square in equation number 2. So instead of H square, we wrote 64 minus A square, and we have only one variable in equation number 2, that is A. So we solved equation number 2, and we found out that A equals to 17 over 4 units, so BE is A and ED also is A, it equals to 17 over 4 units, and we have equation number 1 that states that H square equals to 64 minus A square, and we have already found out that A equals to 17 over 4 units, so we squared this equality and we got that A square equals to 289 over 16. And then we substituted A square by 289 over 16, and we got that the value of H, the height of triangle ABC, H equals to 7 over 4 times root 15 units, and we have already found out that A equals to 17 over 4 units. So we have all the variables of A and H, so we can easily find out the area of triangle ABC, because the area of any triangle, the formula for the area of any triangle equals to the base of the triangle times the height to the base over 2. And the base is BC and the height is H. Okay, so the area of triangle ABC equals to the base BC times the height to the base, that is H, over 2. We know that BC equals to A plus 8, or BC equals to 2A plus 8. BC equals to 2A plus 8, and H, we have already found out that H equals to 7 over 4 times root 15 units. So we can substitute H here by 7 over 4 times root 15, all divided by 2. And we also found out that A equals to 17 over 4 units. So we can substitute A in this equality by 17 over 4. Okay, and we found out that the area of triangle ABC equals to 231 times root 15 over 16 square units. Again, the area of this triangle equals to 231 times root 15 over 16 square units. Okay, so this was method 1 to find out the area of triangle ABC, and then we found that the area of triangle ABC in a second way. In this way, first of all, we found the angle A, the size of angle A, according to the rule that sum of the angles in any triangle equals to 180 degrees. So here we created the equality that states that the sum of the angles in any triangle equals to 180 degrees. So A plus B plus C equals to 180 degrees. Angle A plus angle B plus angle C equals to 180 degrees. And angle A plus angle B is 2x and angle C is x. So we can substitute B by 2x and C by x. So we did it, and we found out that angle A equals to 180 degrees minus 3x. Angle A equals to 180 degrees minus 3x. And then I presented to you rule number 4, that is a new formula for the area of any triangle. According to the new formula for the area of any triangle can be calculated according to the following formula. The area of any triangle equals to A times B times sinus theta over 2. Okay, the area of any triangle equals to A times B times sinus theta over 2. Okay, so we can calculate the area of our triangle ABC according to this formula. So the area of triangle ABC will be equal to AB times AC times sinus 180 degrees minus 3x over 2. Okay, so the area of triangle ABC according to rule number 4 equals to AB times AC times sinus 180 degrees minus 3x over 2. But we know that AB equals to 8 units and AC equals to 14 units. Okay, AB equals to 8 units and AC equals to 14 units. Okay, so we got this equality that the area of triangle ABC equals to 56 times sinus of 180 degrees minus 3x, and we have the trigonometric identity that states that sinus 180 degrees minus alpha equals to sinus to sine alpha. So we can say that sine of 180 degrees minus 3x equals to sine 3x. Okay, according to this identity, sine of 180 degrees minus 3x equals to sine 3x. So the area of triangle ABC equals to 56 sine 3x. Okay, and then I presented to you rule number 5. That is actually the law of sines. According to the law of sines, that you can use it in any triangle. A over sinus A equals to B over sinus B equals to C over sinus C. Okay, A over sinus A equals to B over sinus B equals to C over sinus C. When capital A, capital B, and capital C are the sizes of the angles. The size of this angle is A, the size of this angle is B, and the size of this angle is C. Okay? Again, the law of sine says that A over sine A equals to B over sine B equals to C over sine C. And again, we can implement the law of sines in our triangle ABC. According to the law of sines, AB over sine x equals to AC over sine 2x. Okay, AB over sine x equals to AC over sine 2x. But we know that AB equals to 8 units and AC equals to 14 units. Okay, AB equals to 8 units, AC equals to 14 units. and we have the trigonometric identity that states that sine 2x equals to 2 sine x cosine x. So we can substitute sine x by this expression, and we got that cosine x equals to 7 over 8. Then I presented to you a new trigonometric identity that from this trigonometric identity sine square x plus cosine square x equals to 1. Therefore sine x equals to the root of 1 minus cosine square x. We know that cosine x equals to 7 over 8, so if we square this equality, we will get that cosine square x equals to 49 over 64. Okay, cosine square x equals to 49 over 64. Then we substituted cosine square x by 49 over 64. Okay, here 49 over 64, and we got that sine x equals to the root of 15 over 8. So we can square this equality in order to find the value of sine square x. And we have our first equation states that the area of triangle ABC equals to 56 times sine 3x. And we have trigonometric identity for the value of sine 3x. According to this trigonometric identity, sine 3x equals to 3 sine x minus 4 sine cube x. So we can substitute sine 3x by this expression, and we found that the area, again we know that sine x equals to root 15 over 8, so sine square x equals to 15 over 64. We substituted sine 3x by this expression, and we know the value of sine x and also the value of sine square x. So the only thing that is left is to substitute sine x by root 15 over 8 and to substitute sine square x by 15 over 64, and we find the area of triangle ABC. And we found out that the area of triangle ABC equals to root 15 times 231 over 16 square units. Again, the area of this triangle ABC equals to root 15 times 231 over 16 square units. Okay, thank you very much.